All right, y'all. So 8.5 deals with rational functions. So the first two questions in this section deal with finding the domain. So I'm going to find a domain just to keep us good at doing that. So they want us to find the domain of the rational expression. And we're only writing the answer in set builder notation for this question, okay? So I have f of x equals -1 divided by x squared plus 3x minus 28. Alrighty, so remember on domain, all I'm worried about are numbers that make it undefined, and that's going to deal with that denominator. So set our denominator equal to 0. And then we need to solve this. So this one I'm going to factor to solve. So x squared will give me an x and an x. Since the last number is negative, these will have unlike signs. And then factors of 28, that'll subtract to give me 3 would be 7 and 4. So since 7 is larger, it's got to be positive like the middle number. And then remember, take each of our factors and set them equal to 0. And then once we solve each of these equations, we'll have the two numbers that we need to exclude from our domain. So first I'll subtract 7 and get x is a -7. Second one, we'll add 4 and get x is a +4. So they wanted this wrote in interval notation. So remember, on a rational expression, we always start at -infinity until we hit the first number we're excluding, which is -7. So I'm going to union around that -7 until we come to the next number we're excluding, which is the 4. And then union around that 4 till we head towards positive infinity. So the first two questions is just going back, doing a domain type stuff, just like we did in 5.1 on Tuesday. All righty, so then we're going to get into the new stuff for 8.5. So I'm going to give us a few definitions here on vertical asymptotes, horizontal asymptotes, and oblique asymptote. So first, y'all, I'm going to start with vertical asymptotes. So a vertical asymptote, it's an imaginary vertical line that occurs where a function is undefined. So if it's going to occur where the function is undefined, it's going to occur at these numbers that we're excluding from our domain, because those numbers are numbers that made that function undefined. So an imaginary vertical line that occurs where the function is undefined and the graph cannot cross over the line. Okay, so the graph cannot cross over these imaginary vertical lines, okay? Now, they come in the form of an equation. So they come in the form of x equals that number. So say I had a function that was the one like I did in the example here, and -7 and 4 were the places where it made it undefined. My vertical asymptote would be x equals -7, comma, x equals 4. So they're going to match those numbers, okay? Alrighty, y'all. So now we'll look at what we call horizontal asymptotes. So the horizontal asymptote, it's an imaginary horizontal line that the graph tries to approach as the x values head towards negative infinity and positive infinity. So as these x's get bigger and bigger and bigger, these functions will try to get down to these horizontal asymptotes. Now they never reach the asymptote, but they get closer and closer and closer as you head out towards that infinity or even negative infinity in the left side, okay? Now these also come in the form of an equation. So since these are horizontal lines, they come in the form of y equals some number. Now, the horizontal asymptotes, there's 3 ways that we determine what they're going to be. And what we do to determine the horizontal asymptotes is we compare the degree of the numerator with the degree of the denominator. So remember, the degree is the highest exponent, okay? So comparing the degree of the numerator versus the denominator. So y'all, if the degree on top, which is my numerator, if that degree is greater than the degree of the bottom, so if I got a higher exponent on top than I do on the bottom, then this is the only case where you will have no horizontal asymptote. Because what happens if the degree's got a higher exponent, then the graph is going to try to head towards infinity instead of trying to reach that horizontal line, okay? So the second case, the degree of the bottom has a greater exponent than the top. So the degree of the bottom greater than the degree of the top. So when this happens, the bottom is getting so much bigger compared to the top as you go out towards infinity. So these graphs will always try to approach 0 on the y-axis. So it pretty much 0 for y is on the x-axis. So as you get out towards infinity, they're going to try to get closer to that x-axis. All right, the third case that can happen. Well, the top was greater here, the bottom's greater here. What if they're equal? So the degree of the top equals the degree of the bottom. So if they are equal, then our horizontal asymptotal equal A over B. A is the lead coefficient on top. And B will be the lead coefficient on the bottom. Okay, so if they're both say x to the third, I'm going to look at what numbers are in front to determine what my horizontal asymptote is going to do. So y'all, there's one more case that can happen, and it's what we call an oblique asymptote. Now, this is going to only occur when, so these will occur when the degree on top is 1 degree higher than the bottom. And I think there's only one question where we give you an oblique, okay? But what I mean by 1 degree higher on top than the bottom, so if say I had an x3 on top and an x squared on the bottom, 3 is 1 higher than 2, okay? So these will occur when there's no horizontal asymptote because our top is going to be higher than the bottom, okay? Now, if we do have this happen, then it comes in the form of y equals the leading term on top divided by the leading term on bottom. So notice for my horizontal, in this case, when the top was equal to the bottom, we looked at the fraction that was formed by the lead coefficients. Y'all, when the top is 1 degree higher than the bottom, we're looking at the leading term on top and the leading term on bottom. So the leading term will consist of the number and the variable and the exponent. It'll be that whole term there, okay? So we'll start out with one where we sort of got a list of asymptotes and then graph it, okay? So this will be like number 3 and 4 here. So we're going to list all asymptotes. Then graph. Now I'll tell you, when I'm doing the graphing part, they only give you 4 pictures to pick out of. So when I do the graph, and I'm just going to pretty much punch those in my calculator, okay? And then get the graph, and then we'll pick out one of the graphs when you do them on your math lab. So y'all, 3 is r of x equals 8 divided by x squared minus 81. So they go in order. They'll start with your vertical asymptotes. So I'm going to call that a VA for vertical asymptote. So to find a vertical asymptote, since it occurs where a function is undefined, we're going to take the bottom of our function, x squared minus 81, and set that equal to 0. Now I'm going to solve this by factoring to get y'all good at factoring. But remember, on this one, if you wanted to solve it, you could do add 81 and then do the square root stuff. You'll get the same answer. But y'all, I'm just wanting to work on your factoring a little bit. So x squared will be an x and an x. And actually, this is the difference of perfect squares I showed y'all the other day. So anytime I got two terms being subtracted, always look and see if they're perfect squares. So perfect squares will end up in conjugate pairs. One will be plus and minus. The x's I got because the square root of x squared is x. The square root of 81 will go at the back of this. And the square root of 81 would be, what, a 9. So perfect squares, that was that a squared plus b squared I showed y'all, always equals a plus b times a minus b. So basically, take the square root, put those numbers in front, take the square root of a number, put those numbers in back. All right, y'all. So once we solve this, we will have our two vertical asymptotes. So subtract 9, we get x equals negative 9, and then add 9, and we get x equals a positive 9. So the vertical asymptotes, the answer to MATLAB wants will be x equals negative 9, comma, x equals positive 9. And we got to put the x equal on these because remember, they have to come in the form of an equation for these two lines. All right, so now we'll look for an oblique asymptote. Well, remember, the oblique asymptote occurred when the top was 1 degree higher than the bottom. Well, for us, there's no variable on top, so our top is a degree 0, since there's no variable. Our bottom is a degree 2. So since the top is not a 1 degree higher than the bottom, that means there is no oblique asymptote. So what's left is us to check our horizontal asymptote. So the horizontal asymptote, we had to compare the degree of the top with the degree of the bottom. We had 3 cases. Top was higher, bottom was higher, or they were equal. So y'all, for us, we got a bigger exponent in the bottom of this function. So the bottom degree is greater than the top degree. So on those 3 cases, when the bottom was higher than the top, we said that that horizontal asymptote would be y equals 0. And remember, put that in as an equation. All right, y'all, so that means next, they want us to graph it. So I'm going to show you how to graph these on the calculator. And to make these look like fractions, I always hit the alpha button and the y equal to make that fraction pop up, okay? So let's go to our calculator. So I'm going to go to my y equals. And since this is a fraction, I'm going to hit the green alpha button and the y equals. And then hit enter for ND. That means numerator over denominator. On top, we had an 8. Then I'm going to arrow down. On bottom, I got an x squared minus 81. So x squared minus 81. All righty, now I'm going to hit graph and see what this looks like. Well, y'all, looks like my window needs to be set. So, I'm okay. I remember last week we had them problems going down to the hundreds. So I'm going to set my window, my y minimum, I'm going to set that about -10. And my y max, I'm going to set that at a +10. So if your graph looks funny, it's probably because we're using the window we used last week on those functions there, okay? So now let me hit graph. All righty, so I'm going to draw that real quick. And I'll show you what's happening on it. All righty, so I got that picture. So I'm sort of going to show you real quick on my pad what's going on with this graph. So right here, where it looks like it's going up and this side's going down, this side will go down forever and this side will go up forever towards positive infinity. But they will not cross this line right here because this is the vertical asymptote that happened over here at -9. Same thing on the right side at +9. This is another vertical asymptote. So the graph cannot cross it. So it's just going to keep going down and down and down because it cannot cross over that. Now, the horizontal asymptote, if you was to draw that imaginary line on out, this right side right here is coming down. It's trying to get closer to that 0, but it never gets there. It just gets closer and closer and closer as it heads out towards infinity. So these shapes like right in here are happening on the vertical asymptotes though, okay? All right, y'all, so they would have one looks just like this, one where they got it upside down, and so you'll be able to pick pretty quick which picture you got, okay? All righty, y'all, so let's try this fourth one. F of x equals 3x to the third over x squared minus 16. So once again, I'll find my vertical asymptote, oblique asymptote if I got one, and horizontal if I got one. So starting with our vertical asymptote, we're going to take the bottom of the fraction, set it equal to 0. All right, then we're going to factor that. So y'all, this is the difference of perfect squares again. So since that's perfect squares, what is going in these two parentheses? All right, so let me catch up with my chat. I'm getting what, an x plus 4, x minus 4 plus, perfect. So square root of x was x squared was x and x. Square root of 16, 4 and -4. Good job. So set both them equal to 0. So we subtract 4 on the first one and get -4. We'll add 4 on the second one and get a +4. All right, so those are both my vertical asymptotes. So usually if you got an exponent of 2 in the bottom like these two problems did, you're going to get 2 asymptotes on those, okay? And then remember, keep them looking like an equation. All right, so now we need to check and see if we got an oblique asymptote. So an oblique asymptote happens when the top is 1 degree higher than the bottom. We all look at that. My degree on top is a 3. My degree on bottom is a 2. So that means I do have an oblique asymptote because the top is 1 degree higher than that bottom. So since we got an oblique asymptote, we're going to look at y equals the leading term on top. Well, y'all, there's only one term on top, and that's 3x to the third over the leading term on bottom, which is the x squared term. So notice I'm only comparing the leading terms. That 16 has nothing to do with this part, okay? So I got a 3x to the third over x squared. So the 3 is coming down. And y'all, that x to the third divided by x to the second, 3 minus 2, you're subtracting exponents, that's going to leave you 1x. So the equation of our oblique asymptote will be y equals 3x. So then we look at our horizontal asymptote. Well, y'all, here's the thing. If it's got an oblique asymptote, there's no way it's going to have a horizontal asymptote because that means the top is greater than the bottom. So since my top was a degree 3, my bottom was a degree 2, we said that when the top degree was higher than the bottom degree, there was no horizontal asymptote. Okay. Now on this one, I think on the window, when I'm looking at the graph on it, it went from -10 to 10 on the x's, and then from -2 to +2 on the y values. So I'm going to set my window like that when we graph this. So let me go to y equals. I also want to go y equals and clear this one. And then I'll clear my history over here. So fraction alpha y equals and enter. All right, on top, 3x to the third. So 3x exponent 3. Arrow down to the bottom. We had x squared minus 16. So x squared minus 16. All right, so remember my window, I said the x's went from -10 to 10. But down here on my y's, they went from -2 on the graph to a +2. So set your windows to match their graphs so that you can get these pictures when we graph it. All right, so now I'm going to hit graph. Oh, y'all, let me go back. My bad. My bad. That went, let me fix my window. This is the one where I went from -10 on everything. So make this -10 and 10, and that should get everything on this one. All right, I was looking at another paper. My bad. So now everything's set negative 10, 10, negative 10, 10. So let me graph that. Well, that didn't change much, did it? Oh, my bad. Okay. Window. It was negative 100 and 100 on that. And there you go. So let me go down here and go negative 100. Oh, and I'm wearing my eyes and I can't even see that, y'all. And then, yeah, I think the Y scales they were doing, you don't really have to change the Y scales, but it does give you them tick marks like they're doing. Now let's graph. And there we go. Now, I will say, can y'all see my cursor on the screen? No? So, all right. So let me draw this real quick so y'all see what we got here. So I had at 4 and negative 4, I had my vertical. Okay, it sort of comes down through the center. All right, so I think I got this drawn. So let me see. All righty, so here's the vertical asymptotes at negative 4 and 4. So this graph on this center part, remember, it don't cross over. It's headed towards positive infinity, but it does not cross that line, and it's coming down. And then on this side, it's going to head towards negative infinity, but it's never going to cross that line. So usually if you have one coming up, the other side will come from the down. But look how this one's making this sort of angle. Because y'all, what's happening? That little angle right through there, that's the oblique asymptote. And it's just going to follow that in both directions. It's going to follow that line. And this line was the equation 3x. So if your number's positive, your graph is going to go uphill with that oblique asymptote. If it was negative, then your graph would have sort of a downhill oblique asymptote. But this is the oblique when it causes it to sort of follow that imaginary diagonal line, okay? And then notice there was no horizontal, so it's not trying to get down to this x-axis or anything. It's really just shooting off towards infinity and negative infinity. All righty, so those were the only two we had to really worry about graphing in this section. So the rest of these problems, we're going to be finding vertical asymptotes and horizontal asymptotes. So these ones here will say find the vertical asymptote. All right, these will start at number 5. So I'm sort of going to skip around these because these are just, they're all the same. They just got different things on bottom. So I'll do this one where I got f of x equals 1 over x minus 4 squared. So to find a vertical asymptote, remember, we're going to take the bottom, set that equal to 0. Now, this x minus 4 squared means I got an x minus 4 times an x minus 4. and it's all equal to 0. Now, here's what's nice about this particular problem. Since I got repeating factors, I don't have to solve this but one time. Okay, so after I solve this, I will then have my vertical asymptote. And y'all, I'm just going to come in and add 4. So I get x equals a positive 4. So MATLAB, that's what it wants right there. Okay. All right, I'm going to do 6 because it's one where the factoring is a little different. So y'all, f of x over x minus 3 over x squared plus 3x. All right, so once again, I'm going to take that denominator, set equal to 0. So this one is 2 terms being added. So y'all, let me tell you something about this one. Anytime you got 2 terms being added, the only thing you can do to that is pull out a greatest common factor. Okay, it's not going to factor into parentheses like a trinomial. It's not perfect squares because it's not being subtracted. So the only thing you can do to this is factor out a greatest common factor. And both of these have at least one x. So we would factor out the x in parentheses. We put what we get when we divide both of these terms by the x. So x squared divided by x will leave me an x plus 3x divided by x leaves me a 3. Okay, so set both of these equal to 0. So I get x equals 0 and x plus 3 equals 0. Notice, anytime you factor out an x, it's always going to equal 0, okay? So to get my other one, we would subtract 3, and I get x equals a negative 3. So MATLAB wants both of these. Okay? So really the trick on doing the asymptotes is being able to solve those denominators when you set them equal to 0. So 7 and 8 ain't bad. So let me go to 9 because it had a lot of factoring. So for my number 9, f of x will equal x squared plus 2x minus 15 over x squared minus 4x minus 21. All right. So I'm going to take the bottom of this and we're going to definitely set it equal to 0. So this one's a trinomial. There's no greatest common factor. So we're going to go right into our 2 sets of parentheses. All right, so y'all, why don't y'all factor this one for me? So factor that x squared minus 4x minus 21, and let's see what we're going to put in our parentheses. So let me see, x plus 3, x minus 7. Perfect. So I needed factors of 21. That would subtract and give me 4, 7, and 3. Larger number had to be negative like the middle. And the smaller number, positive. Good job. All right, y'all. Set both these equal to 0. So I'll add 7 and get x equals 7. I'll subtract 3 and get x equals -3. Y'all, let me tell you something. I'm going to show y'all a trick. If you're weak at factoring this stuff, let me show you a trick. I'm going to go to y equals and show you how you can get these two answers without factoring. So let me go to my calculator. We'll go to y equals and clear this out and clear my history over here. Now, I'm not going to graph the whole fraction. I'm just going to graph the x squared part on bottom. X squared minus 4x minus 21. So, since I'm trying to solve this by setting it equal to 0, the two answers will be where this graph crosses the x-axis. And y'all watch this. When I hit graph, look here on the left side. If you go left, you're going -1, -2. It crosses at -3. So that was one of our answers. And if you go right, 1, 2, 3, 4, 5, 6, 7, it's crossing at +7. So you actually get the two final answers if you graph it and look at it. Now, to verify, when I hit second graph and go to the table, look at that. When x was -3, my y value was 0. When I come down here and find 7, my y value is 0. So if you're weak at factoring, the calculator can be used and you can find it where it's crossing those x-intercepts. Now remember, when you do that, it's giving you these final answers, okay? So that graph crossed at -3 and +7. All right, y'all, so that's the answers we want for MATLAB. All righty, so then we're going to do a few of these with the horizontal asymptote. So we're going to determine the horizontal asymptote. Now, we'll say this, that number 4 where I graphed it, that was the only one where you'll have an oblique asymptote, okay? The only one. All right, we're going to determine the horizontal asymptote. We're given f of x equals 3x to the third plus 2 over 2x to the third minus 5. So the first thing I look at is my degree. So my degree on top is 3. My degree on the bottom is a 3. So both of these have a degree 3. So that means the top equals the bottom. Well, y'all, when the top equaled the bottom on those degrees, we said that our equation would be y equals a over b. Okay, so I'm following this pattern, a over b. But remember, a was the lead coefficient on top. So the lead coefficient on top is the 3. B, we said, was the lead coefficient on the bottom, which was the 2. So when your degrees are equal, your horizontal asymptote will be the lead coefficients, okay? Now, y'all, you just got to remember one thing. What if this top was the x3 and it was over a 2x3? If there's not a number shown on top, you got to treat it like a 1, okay? All right, y'all, let's try f of x equals x squared minus 8 over 7x to the 4th plus 4. All right, so let's see. My top is a degree 2. My bottom is a degree 4. So that means the bottom is greater than the top. So y'all, what did we say about those 3 cases when the bottom had higher exponents than the top? Y equals 0, perfect. All right, so one more for this section, and then we'll knock out 8-6. So f of x is going to equal x to the 3rd minus x squared plus 3x minus 2 all over x squared minus 19. So y'all look at this. The top is a degree 3. The bottom is a degree 2. So when the top was greater than the bottom, what happens? So there you go. There's no horizontal asymptote. Now it didn't ask for this, but guess what? This one would have an oblique asymptote because the top x3 would be 1 degree more than that bottom, which was an x squared. Okay. That we didn't have to worry about that on that one, so we're just going to move on. Righty, y'all. So now we're going to look at 8.6, and it's not very long either. It's got like 7 problems, so I'd probably usually do about 5 of them or so. So this is dealing with polynomial inequalities. Now, inequalities are your greater than, less than, greater than, equals, and less than and equals. Okay. Now, we're going to deal with interval notation on our answers. So since we got greater than equals, less than and equals, we got to distinguish between whether we use parentheses or brackets around our numbers. So here's the way I distinguish that. If it's got equals under it, so if it is greater than or equals or less than and equals, we're going to use brackets around our numbers. Okay, because infinity, remember, always uses parentheses no matter what. If it's, say, greater than or less than, I'm going to use parentheses around my numbers. So what that means is brackets, that number is included in the solution. Parentheses means that those numbers are not included in the solution. Just like when we was doing those unions around them numbers, remember we had parentheses because those numbers were getting kicked out of our domains. So the steps to solving polynomial inequalities. So the first thing I'm going to do, I'm going to solve the equation. And remember, I'm going to solve that equation by setting it equal to 0. Now, y'all, once I solve that equation, I'm going to have two solutions. Now, there is one example where the solution is a repeating solution. So I'll show you what to do in that case. But yeah, we should get two solutions on all these. So what we're going to do is we're going to use the solutions and set up a number line. So my number line will have my two solutions. My first one, which I'm calling A, and my second solution, which will be B. So I'm only worried about my two solutions when I make my number line here, okay? So what we got to figure out is where we got to shade this at, okay? So I use a test point. To determine where to shade. Now, y'all, I'm going to tell you personally, I always test 0. No matter where 0 is on here. 0 is the easiest number to plug into those equations and check and see if they're true or false, okay? So I always use 0 to test. Now, here's the thing. When you test 0, if it's true, you shade that area. If it's false, you're not going to shade that area. So if it's false, don't shade the area. Now, y'all, there's two cases that can happen. Okay? Two possible outcomes. If it's true where you tested at, say my 0 was in between A and B and it was true, I would shade that area like that. Now, if it does not shade in between the two numbers, y'all, the only other choice, it's going to shade outside on each of those, okay? So it's either going to shade in between or it's going to shade both ends. So if it's one of these where it shades the ends, these will start at negative infinity, go to the number, and then union from the second number to positive infinity. If it only shades in the middle, it's going to go from the first number to the second number only, okay? All righty. Once we figured out where we're going to shade our numbers, we're then going to write the answer in interval notation. Okay, so watch. I'm going to do my number line with the brackets or parentheses, just like my interval notation, okay? So these aren't bad once you see me playing with some of these. So the first one, we're going to solve the following inequality. Oh, and y'all, I forgot to tell you, there is one case, and you'll see it when I do my last problem. But in the event, say when you're solving it, if your equation cannot be factored to solve, and we cannot solve it, then that means we get what we call a no solution. And I'll show you when we do the no solution, MATLAB uses a 0 with a line through it, okay? So I'll show you how to do that when we hit that one. All right, y'all, so this first one's already factored. X minus 4 times x plus 2 is less than 0. And I'll actually show you a trick on my calculator that sort of matches these type answers, okay? So the first thing we got to do, it said, is solve this equation. So I'm going to take my x minus 4 and my x plus 2 and set them equal to 0 while I solve it, okay? So this is already factored, so set each factor equal to 0. So y'all, the first one, we'll add 4 and solve it. And I get x equals 4. My second one, I'll solve this by subtracting 2. And I get x equals a negative 2. So let me set up my number line now. So let's see, negative 2 will come before my positive 4. Now, like I said, I always use 0 to test it. So I just got to figure out on this timeline or this number line, where is that 0 located? Well, 0 is going to be in between that negative 2 and that positive 4. Okay? So I'm going to test the 0. So to test 0, I'm going to put 0 into this equation and see if that's true or false. So that'll be 0 minus 4 times 0 plus 2. That has to be less than 0. Well, y'all, 0 minus 4 gives me a negative 4. Second parenthesis, 0 plus 2 gives me a 2. That has to be less than 0. So y'all, let's see. Negative 4 times 2, that's going to give us negative 8 less than 0. So that is definitely true. Negative 8 is less than 0. So that's true. So I shade where 0 was located. So shade where 0 is located. So let me draw my line again. So I had -2 and 4. Well, 0 was located in the middle. Now, here's my first question to y'all. Would y'all use brackets or parentheses for this? So remember, we're looking at the inequality. That is just a less than.
You're going to use parentheses.
I'm going to use parentheses. So I got my parentheses. And then we're just going to shade it in between where that 0 is located. Now, we got to write our answer in interval notation. And y'all, that's why I like using the parentheses and stuff here, because interval notation is parentheses, -2, comma, 4. So remember, when it shades in between, your interval will just be one set of parentheses or one set of brackets, depending on whether you got it equal or not, okay? Alrighty, y'all, so let's play with more of those. So number 2, I got an x squared minus 13x plus 40. All of that is greater than 0. Alrighty, y'all, so I'll actually show y'all this one on the calculator. I forgot on the last one. I think I said I was going to. I'll show you on this one. But I'm gonna factor that, set it equal to 0. So y'all, this will be an x and an x. Since that last one's positive, both of these will be negative like the middle. And I guess we need factors of 40. That'll add to get me a 13. So you got what, 1 and 40, but that don't work. 2 and 20, that don't work. 4 and 10, that don't work.
It's going to be 8 and 5.
8, yeah, 8 and 5, that'll work perfect, and they're both going to be negative, remember. Alrighty, so set them equal to 0, and we'll get our two numbers. So I got to add 8. I get x equals a positive 8. I'm going to add 5. And I get x equals a positive 5. So 5 will be before 8. But y'all, here's where you got to pay attention, because 0 is not going to be in the middle this time. 0 ain't between a 5 and an 8. 0 is going to be over here somewhere to the left of the 5. So I know my 0 is going to be in that section. Now, here's what's going to happen. When I test 0, if it's true, I'm going to shade the region it's in. And I'm also going to shade the right side. Because if I shade the left side, I got to shade the right side. But if it's false where my 0 is located, I'm not going to shade that, which means the only section I'll shade will be the middle. Okay? You either shade the middles or the outsides. So y'all, let's test that 0. That'll be 0 squared minus 13 times 0 plus 40 has to be greater than 0. Now, the reason I like 0, because 0 squared is gone. 13 times 0 is gone. All that's left is that 40. So 40 greater than 0. That is definitely true. So we're going to shade the section where 0 was located and the right side there. So here's 5. Here's 8. Now the question would be, around these numbers, will I use parentheses or brackets?
Parentheses.
Yeah, because I'm looking at that less than again. Now, since we're shading over here, my parentheses are going to face these two ends here and then to the right. So remember, when you got these ends shaded, this left side in interval notation is coming in from negative infinity until we hit that positive 5. And we got our parentheses, union, parentheses, and y'all, the right side starts at 8 and heads towards infinity. So y'all are not too bad. You just got to keep up with where that 0 is, okay? All right, so let's see what they're doing here. This one, they're giving us an x squared. Oh, my bad. Let me show you. Now notice, this said greater than 0. So notice, it's greater than 0 from negative infinity to 5 and from 8 to infinity. So I'm going to show you what that graph will do. I'm going to go to my calculator. Y equals, and I'm going to clear that out. So we had an x squared minus 13x plus 40. Now remember, since this is greater than 0, 0 is the x-axis. So watch what part of this graph is going to be above the x-axis. Now let me make sure I'm going to put them hundreds back to 10, okay? I'm going to go negative 10 here. I'm going to go back to positive 10 for my max. And I'm going to change that scale back down to a 1. All righty, so my window's back. Now I'm going to hit graphs. So y'all, look at the part above the x-axis. Well, this one looks like it's 1, 2, 3, 4. It's stopping at 5. So the left side's coming downhill over here to the 5, but all that's above. So that means it's greater than 0. And then over here, it starts at, what's that, 6, 7, 8. At 8, it's above the x-axis on that right part. So the only part that was underneath the x-axis was that part between R5 and 8. So you can sort of look at the graph, and if you're greater than, you're above the line. Less than would be below the line, okay? All right, y'all, now, so this 3 has x squared plus 7x minus 22 is going to be greater than or equal to x minus 6. So here's the thing on this one. On this right side, I need a 0. So we need to move both of these to the other side. So I'm going to move the x by subtracting an x from both sides. I'm going to move that negative 6 by adding a positive 6 to both sides. So we're going to move both of them at one time on this, okay? So bring down the x squared. 7 minus x leaves us 6x. Negative 22 plus 6 gives us a negative 16. And at this point, I'm just going to set them equal to 0 so we can solve it. Okay, y'all, looks like we get to factor some more. Now remember, if you can't factor this, plug it in y equals and see where this thing's crossing the x-axis at. So if you can do that, it'll be the same thing as getting the answers I'm going to get from factoring this. All right, that's negative, so I got unlike signs. What factors is 16? That'll subtract and give me 6. Will be what, an 8 and a 2. So the 8's larger, it's going to be positive, and a 2 negative. All right, y'all, set both these equal to 0 so we get our 2 test points. So we're going to subtract 8 on our first one. Add 2 on the second one. So negative 8 and 2. So that means 0 for me. It's going to be in between that negative 8 and 2 this time. So I'm going to test my 0 to see if this is true or false. So I'm going to use this original equation. So I got a 0 squared plus 7 times 0 minus 22 has to be greater than or equal to 0 minus 6. Well, 0 squared is gone. 7 times 0 is gone. So the left side is negative 22. That's got to be greater than or equal. And on the right side, the 0's gone, so that's just a negative 6. So negative 22 greater than negative 6 is false. Remember, any number to the right of another number is greater than that number. So remember, negative 6 would be right in here. Negative 22 is way over here. Okay. So we don't shade where the 0 was located. So let me draw my line. There's negative 8 and 2. So y'all, if I'm not going to shade where the 0 is located, I got to shade the outsides of this. So the first question, do I want parentheses or brackets around these numbers?
You're gonna use brackets.
I'm going to use brackets. Good job, because that thing's got that equals in it. So I know I'll have a bracket facing that way and a bracket facing that way. And then I just shade those edges. Okay. So interval notation, parentheses for your infinities, remember. So from negative infinity, it'll go to negative 8. We'll use our bracket, and then union bracket from a positive 2 to our positive infinity. So y'all are not too bad. The trick is being able to solve them for your two numbers and then setting up that number line and testing a test point. Now, I ain't going to lie. You can test any number you want to, okay? But 0 is probably the easiest one that you can plug in and get done really quick, okay? All right, y'all, this one has an x squared greater than 9. Now, at this point, you could take square roots of both sides, okay, and solve this one. Anytime you just got an x squared in a number, you can do square roots. But I'm going to get y'all good at factoring. So I'm going to get this right side to be 0 by subtracting 9. So that's going to give me x squared minus 9. And remember, I'm going to set it equal to 0. And y'all, I'm just doing this to get y'all more practice at factoring these perfect squares. So since that's perfect squares, what does this x squared minus 9 factor into?
Will it be x plus 3 and x minus 3?
Oh, that sounds good to me. There you go. And then we'll just set those equal to 0. So now if you'd have did square roots, you'd have got these two answers I'm about to get. You'd have got that -3, and then you'd have got a +3. So remember, square root of 9 would have been a plus or minus 3, okay? All righty, so let's set up our little our number line. We got a -3 here and a +3. So y'all, 0 will be right in between them this time. So I'm going to test my 0. So I'm going to use this equation. I got 0 squared greater than 9. So y'all, true or false, 0 greater than 9. So that is definitely false. So we're not going to shade that where that 0 is. We're going to shade the outsides. So on this one, would y'all use parentheses or brackets? So y'all got a greater than. So on greater than, I'm going to use
Parentheses.
parentheses. And since I'm shading the outsides, I'm just going to turn them to the outsides and shade it. But y'all, that makes sense. X squared greater than 9. Any number in here, -2 squared is 4. That's false. 0 squared was 0. That made that false. When you pick numbers out here like -5 and 5, -5 times -5 is 25. Well, 25 is greater than 9. 4 squared is 16. 16 is greater than 9. So all that stuff we shaded makes that true. All right, let's see. We use parentheses, so we're going to go from -infinity to -3, union +3 to our positive infinity. All right, y'all. So, like I said, the trick on these is just getting them solved. So I'll probably knock out the other 3. Looks like we got enough time I can knock out these other 3. So 5 is 25 minus x squared less than or equal to 0. So once again, I'm going to try to solve it by factoring. So I need these in order. So I'm going to rearrange it so that I get a -x squared plus 25 equal 0. And I'm going to tell you one more thing I would do. To make this x squared positive, because I don't like my x squared terms being negative. So to make this x squared positive, I'm dividing everybody by a -1. So -x squared divided by -1 plus 25 divided by -1 will equal 0 divided by -1. So you can multiply or divide by anything as long as you do it all the way through here, okay? But notice what will happen. That's going to give me a positive x squared minus 25 equal to 0. So y'all, guess what? It's time for y'all to factor x squared minus 25. What are we about to put in these parentheses?
You're gonna have x plus 5 and x minus 5.
There you go.
0.
Got them perfect squares again, y'all. All right, so now we're just going to change these two signs over and get my 2 points. So I get a -5 and a +5. All right, so here's -5. Here's +5. And y'all, once again, my zero's right in between. So let's test 0 and see what happens. So I got 25 minus 0 squared. That has to be less than or equal to 0. All right, so 0 squared is 0. So I get 25 less than or equal to 0. Well, y'all, that one is definitely false again, because 25 is greater, not less than. So that's false. So we're not going to shade the middle again. We're going to shade the outsides. Now, that has equals under it. So once again, we're going to use brackets. So interval notation from -infinity to -5, bracket, union, bracket, from 5 to +infinity. All right, let's see. 6, I got 10x minus 25 minus x squared is less than 0. So this one to me is like 5. I'm going to put everything in order, and then I'm going to make that x squared positive again, okay? So first putting them in order, -x squared plus 10x minus 25. We'll make that equal to 0. Now remember, I don't like that negative, so I'm going to divide everybody by -1. Okay, so always try to get your leading term to be positive. So that's what's going to happen here. I'm now going to get a positive x squared minus 10x plus 25 equal to 0. So we can now factor that. X squared to be an x and an x. The last one's positive, so these will both be negative like the middle. And factors of 25, that'll add to get me a 10. That's what, a 5 and a 5. But y'all look at this. This is one of those where I got a repeating answer. So when you get one of these with a repeating answer, let's see, right here, let's say this is well, we'd have to solve it first. So we only have to worry about setting one of them equal to 0. And we'll finish this by what? Adding 5. And I get x equals a +5. So over here on the number line at that 5, since I've only got one answer, I'm going to draw it as a hollow circle. Because when you got a single answer, that's the only number we exclude from the domain. So that's the only number we exclude from, oh, not the domain, but from the solution set. How about that? So that means everything else is going to be shaded up to that 5. Everything after the 5 is going to be shaded. Everything's shaded, but we got to kick out that 5. For y'all to do that, we go from negative infinity up to that 5, union around that 5 until we hit positive infinity. Now you'll notice this on the ones where you get the repeating answer, there's not going to be a bar under here. Because if it was equals, then that would have been true for every single number. Because 5 would have made it true because of the equal part. But that didn't have equals, so that's why we're kicking out that 5, okay? So y'all's number 6 will be pretty much like mine. You should just get one number on that, okay? All right, y'all. So 7 has an x squared plus an 8 less than 4x. So I need a 0 here. So we're going to subtract 4x from both sides. So I get my x squared minus my 4x plus my 8. And at this point, I'm going to set it equal to 0. All right, so that means it's time to factor this. So I got an x and an x. Last one's positive, so both of these will be negative. All right, y'all, find me factors of 8. Factors of 8 that'll add to get a 4. Well, y'all, guess what? 1 and 8 add to get a 9, so that don't work. 2 and 4 add to get a 6, so that don't work. So guess what? This one does not factor. So since this does not factor, there's what we call no solution. So when there's a no solution in MathLab, they'll have the x equals part, and instead of writing interval notation for no solution, there'll be an option on the little bar down there where you got the fractions and the exponents and stuff. You'll see like a 0 with a line through it. That thing right there means no solution. So use that in that answer blank, okay? All righty, y'all. Question on those. So, y'all, that was everything up to 8-6. So that covers the material for our third test.